means reducing emissions from deforestation and forest degradation. Uh, REDD means reducing emissions from deforestation and forest degradation. Another one is the ecosystem service evaluations. Okay, I will share some PPTs. Second one is the soil erosion. What is the soil erosion? Soil erosion is the detachment. Okay, soil erosion. Soil erosion is the detachment and transportation of topsoil by agents such as water, wind, ice, or gravity. Okay, topsoil erosion is the types of soil erosions. What are the types of? There are five types of soil erosion. Is there? First one is the sheet erosion, rill erosion, gully erosion, and wind erosion, and stream bank erosion. I repeat once again: sheet erosion, rill erosion, gully erosion, wind erosion, and streamback erosion. What are the causes of soil erosion? Main causes of soil erosion is the deforestation and overgrazing, unstable agriculture practices, construction and mining, heavy rainfall and floods. Okay, what are the consequences with the soil erosion? One of the main consequences are loss of fertile topsoil. Okay, loss of fertile topsoil. Reduced agriculture productivity, sedimentation of rivers and reservoirs, and nutrient depletion is there. Increased flood frequency is there. Okay, uh, another one is the desertification. What is the desertification? Desertification is the degradation of land in arid and semi-arid and dry humid regions. Okay, primarily due to climatic variations and human activities. Okay, in Indian context, most affected Thar Desert region. Okay, Thar Desert region. Okay, governed internationally by United Nations convention to combat desertification. Okay, main causes of desertification means climate change and prolonged drought and overgrazing and deforestation and unstable irrigation leading to salination. Okay, over exploration of groundwater. Okay, some impacts is there: decline in soil fertility, loss of vegetation cover, food insecurity, rural poverty and migration, dust storms and micro limitic changes is there. Advanced concepts is there. Some advanced concepts are land degradation, neutrality and salinization and alkalization process, and remote sensing in desertification monitoring is there. The another one is the last one is the urbanization and industrialization. Okay, urbanization refers to the expansion of cities and towns, while industrialization refers to the growth of manufacturing and industrial activities. Some drivers are is there: population growth, economic development, rural to urban migration, infrastructure expansion is there. Okay, some environmental impacts also is there. Main environmental impacts are conversion of agriculture land to built up areas, soil sealing, loss of permeability. Okay, solid waste accumulation is there, land contamination like heavy metals, hazardous waste. Okay, heat island effects. Okay, heat island effects is there. Uh, like industrial disasters like Bhopal gas tragedy highlight risk of improper land use planning. Okay. Some advanced concepts is there: suitable urban planning and brownfield redevelopment, environmental impact assessment is like a circular economic approach is there. Interlinkage between major land problems are deforestation like soil erosion and loss of topsoil. Okay, soil erosion, desertification, land productivity decline. Okay, urbanization problem linked to deforestation. The result is habitat fragmentation. Industrialization problem linked to land contamination result is public health risks. Okay, major land problems are interconnected and cumulative, leading to ecological imbalance and socio-economic instability. For sustainable land management, ecological principles and socio-economic drivers is the policy framework is there. Okay, uh, coming to the next slide. Importance of forests. Forests are complex terrestrial ecosystems that provide critical ecological services and substantial economic benefits. They play a foundational role in maintaining biospheric stability, supporting biodiversity, regulating climate, and sustaining livelihoods. Okay. First one is the commercial and ecological roles. What is the commercial roles of a forest? Economic importance is there. Forests contribute significantly to national and global economics through timber extraction, non-timber forest products, and ecosystem services valuation is there. In India, forest resources are monitored by Forest Survey of India and regulated under frameworks such as the Forest Conservation Act. First one is the timber protection. Construction materials like teak, sal, and pine, furniture industry, railway sleepers and plywood, paper and pulp industries. Fuel wood is there. Major energy source in rural and tribal areas, biomass energy production, charcoal manufacturing. Okay, raw materials is there. Some raw materials are bamboo, uh, paper and handicrafts. It uses for papers and handicrafts. Okay, resins and gums, latex, medicinal plants is there, essential oils and tannins and dyes is there. Okay, there are classified as non-timber forest products and are vital for tribal economics. Okay, and ecological roles of foresters are often described as the lungs of the earth because of their role in carbon cycling and oxygen production is there. A carbon sequestration and climate realization, forests absorb atmospheric CO2 via photosynthesis and store carbon in biomass, deadwood, and litter and forest soil. Okay, some water regulations. It means hydrological functions. Forests regulate the water cycle through interruption of rainfall and infiltration enhancement, groundwater recharge is there. Transpiration are effects of reduction in flood intensity, prevention of soil erosion, stabilization of stream flow, maintenance of watershed health. Okay, some uh, micro climate and macro climate control is there. Temperature moderation, humidity regulation, and wind speed reduction, cloud formation pattern is there. Okay, biodiversity conservation is there. Forests harbor 80% of terrestrial biodiversity and keystone species is there. Endemic and endangered flora and fauna. Okay, they maintain genetic diversity, trophic interactions, and ecological religions. Okay, some soil conservation is there. Forest prevent sheet and gully erosion, landslides, nutrient leaching. Okay, coming to the next slide. Ecological functions of forests. What is the functions for forest? Forest functions as self-regulating ecological systems that maintain environmental stability at local, regional, and global scales. Their ecological roles are best understood though through ecosystem ecology, biological cycling, and landscaping level interaction. Okay, in this first one is the soil conservation. Okay, forest prevents soil degradation through multiple purpose. One is the root binding, litter layer protection, hydrological regulation. Okay, in second one is the carbon absorption. Forests act as major carbon sinks, playing a crucial role in climate change mitigation. In this first one is the photosynthesis synthesis and carbon storage. Okay, and climate feedback mechanism like regulating atmosphere CO2 concentration, influence albedo and evapotranspiration and affect regional precipitation patterns. Okay, and biodiversity conservation is there. Okay, third one is the biodiversity conservation. In these forests are most biodiverse terrestrial ecosystems. In this habitat prevention, genetic reservoir, and ecological stability is there. Okay. Last one is the pollution and noise reduction. What is the pollution and noise reduction? In this first one, the air pollution control. Forests act as biological filters by absorbing gases, pollutants like CO2 and nitrous oxides and sulfur dioxide. So, trapping particulate matter on leaf surfaces, releasing oxygen through photosynthesis. Okay, and another one is the noise reduction. Trees belts act as sound barriers. Dense vegetation absorbs and deflects sound waves, useful in roadside plantation and industrialization zones. Okay, into, into the next slide. Forest management systems. In this forest management systems are scientific approaches used to regulate forest structure, composition, and regeneration, and yield to achieve long-term goals of productivity, sustainability, and ecological stability. The central aim of forest management is to balance economic productivity, ecological integrity, and social and livelihood needs. Okay. In this first one is the even-aged forest management. In this even agent management refers to a system in which a forest stand consists of trees of approximately the same age or age class usually established after a single regeneration event. Um, in this structural characteristics there, it means single age coat and often a monoculture plantation is there. Regeneration methods is some regeneration methods is there, clear cutting system, sheet or wood system, seed tree method. Okay, some limitations is there, reduced biodiversity, alters micro. Uh, okay, second one is the uneven aged management. Uneven managed management maintains a forest stand composed of three or more distinct age classes, promoting continuous regeneration is there. Structural characteristics are multi-layered canopy and mixed age structure, high structural complexity, greater reaction to natural forests. Okay, regeneration methods are selection system, continuous cover forestry, and maintain cover forest. Okay, some productivity and sustainability. Last one is the aim, productivity and sustainability. What is the productivity? Modern forest management integrate economic forestry with ecological principles like productivity, minimizing timber and non-timber forest products, enhancing net primary productivity, genetic improvement, and silver culture treatment. Okay. Second one is the sustainability. Sustainability implies maintaining forest cover over time, preserving biodiversity, protecting soil and water resources, ensuring carbon balance. The Food and Agriculture Organization defines sustainable forest management as management that maintains ecological, economic, and social functions without compromising future generations. Okay, international climate frameworks such as the uh, inter intergovernmental panel and climate change is emphasized suitable for forestry as a mitigation strategy. Okay, coming to the next slide. Forest harvesting methods. Forest harvesting methods are um, sil- silvicultural techniques used to remove trees for timber while ensuring regeneration and sustained yield and ecological balance. These methods influence forest structure, biodiversity, carbon dynamics, and soil health. Sorry. Harvesting systems are broadly organized with even engaged and uneven edged management system. First one is the selective cutting. Selective cutting involves the removal of individual trees or small groups of trees at regular intervals, maintaining a continuous forest cover and uneven edge structure. Okay, and second one is the settler wood cutting. It means settler wood cutting removes mature trees in a series of stages, allowing regeneration under the partial shade of remaining trees. Okay, stages of shelter wood system is uh, property cut. It means enhanced seed production and seed cut. Seed cut means creates the space of regeneration. Removal cut. It means removes remaining mature trees. Okay. Second one is the seed tree cutting. The third one is the seed tree cutting. It means it is the method most trees are removed, but a few superior seed bearing trees are left standing to provide natural regeneration. Some characteristics are there, even aged regeneration, few dominant trees retained temporarily, often used for lighting and demanding species. Okay. Uh, Last one is the clear cutting. Clear cutting involves the complete removal of all trees in a defined area in a single operation. Uh, some ecological impact is with clear cutting apparent soil erosion risk and habitat fragmentation, loss of biodiversity, and increased runoff and sedimentation. Temporarily reduction in carbon storage is there. Okay. Uh, Agriculture land management. Agricultural land management refers to the scientific planning, utilization, and conservation of land resources for crop and livestock production while maintaining long-term soil fertility, water availability, and ecological balance. It integrates agronomy, soil science, hydrology, ecology, or agriculture economics. In this first one is the industrialized agriculture. What is the mean by industrialized agriculture? It means industrialized agriculture is a large scale mechanized input intensive farming system aimed at minimizing maximizing productivity and profit. Okay, I repeat once again, industrialized agriculture is a large scale mechanized input intensive farming system aimed at maximizing productivity and profit. Okay, some key factors are monocropping systems, high yielding varieties is there, heavy use of synthetic fertilizers and pesticides, mechanization like machinization like tractors and harvesters, irrigation dependent. Okay, some objectives are there: high productivity per unit area, market oriented production, export driven agriculture. Okay, second one is the sub subsistence agriculture. It means subsistence agriculture is a small scale farming system where crops are grown primarily for household consumption rather than for commercial scale. Some characteristics are there: small land holdings, mixed cropping, family labor, low external inputs, and traditional tools and indigenous knowledges. Okay, so types are shifting cultivation, rain-fed farming, mixed farming systems. Okay, some advantages in there: maintenance crop diversity, low ecological footprint, sustainable nutrients recycling, and community religions. Okay, some limitations is there and low productivity is there, vulnerable to climate variability, limited market integration, poverty traps is there. Okay, and third one, the green revolution technologies is there. The green revolutionary refers to the introduction of high yielding varieties, irrigation expansion, and chemical fertilizers and pesticides to increase agriculture productivity, particularly in developing countries during the 1960s to 1980s. The movement was globally associated with Norman Borlaug and implemented in India under policy leadership during the 1960s. Major components of high-yielding drought varieties, chemical fertilizers, pesticides and herbicides, acid irrigation, institutional credit and subsidies. Okay, achievements are increased food grain products and improved food security, reduced farming risk and agriculture modernization is there. Environmental consequences also there. Soil nutrient imbalance and groundwater over extraction, salination and water logging, decline in crop genetic diversity, increased chemical pollution is there. Okay, some ecological perspective of on agricultural land management. Agriculture systems are agro ecosystems influenced by soil nutrient cycles and water balance is there, carbon dynamics there, human management practices there. It in this agricultural land management must reconcile food security, environmental sustainability, climate resilience, and economic variability. Okay. Uh, Coming to the next slide, soil conservation methods. What is the soil conservation method? In this, soil conservation refers to the protection, preservation, and sustainable management of soil resources to prevent erosion, maintain fertility, and ensure long-term agriculture productivity. From an ecological perspective, soil conservation maintains a nutrient cycling, soil organic matter, microbial diversity, hydrological balance, and carbon subsequence is there. First one is the conservation tillage. What is the mean by conservation tillage? It means conservation tillage is a farming practice that minimize soil disturbances and retains crop residues on the soil surface. In this, some types is there: no-till farming, reduced tillage, mulch tillage. Okay, some mechanism is there: crop residue protect soil from raindrop impact, reduce surface runoff. Okay, enhance infiltration and moisture retention. Okay. Second one is the counter farming. What is the counter farming? Counter farming involves plowing and planting across the slope, following the natural counter lines of the land. Okay. Some mechanisms is there: slow down surface runoff, reduces volatility of flowing water, encourage water infiltration is there. Okay. Some ecological benefits there: minimize the sheet erosion, prevents nutrients loss, improves water retention. Okay. Uh, Third one is the terracing. What is the terracing? Terracing converts steps slopes into a series of flat or gently sloping steps, reducing runoff and soil losses. Okay. Types are bench terraces and board-based terrace and graded terrace. Okay. Applications are mainly in the widely used in mountainous regions such as the Himalayas and other hill agriculture landscapes. Some limitations are there: high concentration cost, maintenance intensive, risk of terrace failure of poorly designed. Okay. Fourth one is the strip cropping. Strip cropping means strip cropping involves growing alternate strips of different crops, especially combining erosion prone crops with soil protective crops. Mechanisms are slow wind and water movement, reduces soil particle detachment is there, improves nutrient cycle. Okay, types are counter strip cropping, field strip cropping, and buffer strip cropping is there. Ecological advantages are enhance biodiversity, reduces pest outbreaks, and improves soil fertility. Okay. Last one is the windbreak. Okay. Definition in this definition, windbreaks are rows of trees or shrubs planted perpendicular to prevailing winds to reduce wind velocity and prevent wind erosion. In these mechanisms, reduced wind speed, trap moving soil particulates, and protect crops from uh, desertifications. Okay. In these main conclusions, soil conservation methods are essential for maintaining soil fertility, preventing land degradation, enhancing agricultural sustainability, supporting climate resilience. Okay, coming to the next slide. Grasslands. Regions dominated by grasslands are types of tropical temperature polar, important for grazing and biodiversity. First one is the grasslands. Grasslands are terrestrial ecosystem uh, dominated by grasses and uh, herbaceous plants with few or no trees. Their structure, productivity, and species composition are primarily determined by climate, fire regions, and grazing pressure and soil characteristics there. They cover nearly one third of the Earth's land surface and play a crucial role in global carbon cycling and biodiversity conservation is there. Okay. Types of grasslands. Uh, tropical grasslands. Some tropical grasslands are there, are located between tropical rainforest and deserts, and restrict wet and dry seasons, and scattered trees like baobab and acacia, and high herbivorous biomass is there. Climate is temperature high year round, and rainfall is the 5 to 500 to 1500 millimeter annually. Okay. Second one is the temperature grasslands. What was temperature glaciers found in mid latitudes, and few or no trees. Deep fertile soils is there. Climate is moderate rainfall, uh, like 250 to 750 millimeters. Cold winters and warm summers. Okay. Third is the polar grasslands. Polar grasslands are located in high latitude regions dominated by grasses, mosses, leeches. Absence of tall trees, climate is extremely cold temperature, start growing season, and perform for frost and presents. Ecological roles are major carbon storage in frozen soil, are sensitive to climate warming is there. Okay. Uh, Last one is the importance of grasslands. Importance for grazing and biodiversity. In this, grazing and livestock production is grasslands are primary sources of natural forage for livestock and dairy and meat production. Pastoral livelihoods is there. Overgrazing, however, may lead to soil compaction and desertification. Biodiversity conservation in this, grassland support to large herbivores, predators, ground nesting birds, pollinators, and soil microorganisms is there. Okay, some carbon sequestrations is there. Unlike forests, much of grassland carbon is stored below ground in root system and soil organic matter. Deep root network enhance carbon storage. Grasslands may be more suitable stable carbon sinks under drought conditions. Okay. Last one is the soil and water conservation. And to prevent wind erosion, improve soil aggregation, and enhance infiltration, reduce surface runoff. Okay. Coming to the next slides, grassland management. How grassland management? Grassland management refers to the scientific regulation of grazing pressure, vegetation composition, and soil health to maintain productivity, biodiversity, and ecological stability. From an ecological perspective, grasslands are disturbances driven ecosystems where grazing and fire play regulatory roles. Substantial management ensures that grazing does not exceed the carrying capacity of the land. Okay. Stocking rate control is the stocking rate refers to the number of animals per unit area of land over a specific period. Okay. Ecological impacts of overgrazing like soil compaction and reduced infiltration, loss of palatable species, and increased intensive species desertification risk is there. Okay. Application contexts are in ecosystems such as the Serengeti natural herbivorous population regulate vegetation through dynamic equilibrium. In managed system, humans must stimulate this balance scientifically. Okay. Second is the rotational grazing. What is the rotational grazing? Rotational grazing involves dividing pasture into multiple paddocks and moving livestock periodically to allow vegetation recovery. In these mechanisms, resting periods promote regrowth and enhance root development, improve soil organic matter, reduces selective overgrazing. Okay, some types are is there simple rotational grazing, defer grazing, and holistic plant grazing. Okay, ecological benefits is there: improved biomass production, increased biodiversity, and better nutrient cycling is there. Enhanced soil carbon sequestration is there. Okay. Third, last one is the weed control and reseeding. Weed control and reseeding: weeds compete with native grasses for nutrients, water, and light. Okay. Methods are mechanical removal, controlled burning, biological control, and selective herbicides. Okay. Coming to the next slide, chemical fertilizers. What is the chemical fertilizers? Mainly, chemical fertilizers are synthetic or industrially manufactured nutrient sources used to supplement soil fertility and enhance crop productivity. They primarily supply essential micronutrients like nitrogen, phosphorus, and potassium. It means NPK, required for plant growth. Their widespread use expanded significantly during the Green Revolution period and remained central to modern agriculture in certification. Okay, nutrient compositions like NPK, N means nitrogen. These functions are essential for chlorophyll synthesis, promotes vegetative growth, key components of amino acids and proteins. Common forms are urea, ammonium sulfate, and ammonium nitrate. Soil dynamics in highly mobile and subject to leaching and volatilization, converts via nitrification and denitrification. Okay. Second one is the phosphorus. Phosphorus functions are energy transfer like ATP, root development and flowering and seed formation. Common forms are single superphosphate and diammonium phosphate. Okay. Soil behavior like low mobility often becomes fixed in soil. Efficiency depends on soil pH. Okay. Last one is the potassium. It means regulatory stromal opening, enhance drought resistant, improves disease resistance. Okay. Common forms of nutrients of potash, sulfate of potash. Okay. Soil behavior like moderately mobile and influence osmotic regulation is there. Okay. Main role is the role in increasing crop yield like rapid nutrient availability, high productivity per unit area, improved grain size and quality. Okay, coming to the next slide. Okay, environmental impacts of fertilizers. In this, the excessive or imbalanced use of chemical fertilizers, primarily nitrogen, phosphorus, and potassium, has significant environmental consequence. While fertilizers increase crop productivity, their mismanagement disrupts bio geochemical cycles, affects soil health, contaminates water resources, and impact human health also. Okay, in this eutrophication. First one is the eutrophication. Eutrophication is the nutrients enrichment of water bodies, leading to excessive growth of algae and aquatic plants. Okay, some mechanisms is there: fertilizer supplied to fields, rainfall causes surface runoff, nitrogen and phosphorus enter rivers, lakes, reservoirs. Okay, rapid algal bloom formation like oxygen depletion, fish mortality and biodiversity is like ecological consequences: algal blooms, black sunlight, reduced dissolved oxygen, collapse of aquatic food webs, and toxic cyanobacteria blooms are there. Okay. Second was the groundwater contamination. Groundwater contamination means mechanisms are nitrogen fertilizers, especially nitrates, are highly soluble and leach through soil profile into groundwater. Sources are over application of urea and ammonium fertilizers, irrigation induced leaching, poor drainage system is there, environmental and health impacts is there, drinking water contamination risk of methoglobinia like long-term carcinogenic risks is there. Okay. Third one is the soil degradation. Soil acidification is there. Excess nitrogen fertilizers increase ion, hydrogen ion in concentration, lowering soil pH. Okay. Salinization means irrigation combined with fertilizers may causes salt accumulation, especially in arid regions. Okay. Nutrients imbalance is there. Overuse of nutrients reduced micronutrient availability and decline in soil organic matter, reduced microbial diversity is there. Ecological impacts of reduced soil fertility over time and decreasing soil structure stability, overcropping. Okay. Last one is the health effects. Direct effects are nitrate contaminated drinking water, exposure to heavy metals in phosphate fertilizers like cadmium. Indirect effects are nitrous oxide emissions contribute to climate change, air pollution from ammonium volatilization, and food chain contamination is there. The World Health Organization sets limits for nitrate levels in drinking water due to associated health risks. Okay. Uh, Decertification is there. A definition of decertification. What is the decertification? Decertification Desertification refers to the degradation of land in arid, semi-arid, and dry humid regions, resulting reduced biological productivity, the formation of fertile land into desert-like conditions. According to the United Nations Convention to combat desertification. Desertification is driven by climatic variation and human activities. It is not simply the expansion of existing desert, but a purpose of ecological decline and loss of land productivity. Okay. Causes of desertifications are overgrazing. First one is the overgrazing. Excess livestock pressure behind the carrying capacity, removal of protective vegetation covers, and soil compaction by trampling and reduced infertilization and increased. Okay. Some ecological impact is there. Decline in palatable species and deforestation is there. Another one is the mismanagement of land. Mismanagement of land means unsustainable agriculture, excessive tillage and monocropping, improper irrigation is there, poor irrigation practices like water logging, salt accumulation, and decline in soil fertility. Recurrent burning means desertification of vegetation cover, nutrient volatilization there. Uh, Last one is the climate change linkage is the rising suitable grazing management is there. Desertification is a complex socio-ecological process resulting from the interaction of human pressure and climatic variability is there. Okay. Uh, like dams benefits and impacts. What is the dams benefits? Dams are large structure built across rivers to store, regulate, and control water flow for multiple purposes such as irrigation, hydropower generation, flood control, and water supply. While dams contribute significantly to economic development, they also cause major ecological and social transformation in basins. River basins. Benefits of dams. First one is the irrigation. Irrigation dams store monsoon or seasonal rainfall and provide regular water supply for agriculture. Advantages are expansion of irrigated agriculture, increased crop yields, multiple cropping system, and reduced drought vulnerability. Second one is the hydropower generation. Stored water is released through turbines to generate electricity. It means renewable energy sources like energy security, low optional greenhouse gas emission supports industrial development. Second one is the flood control. What is the flood control? Dams regulate excess river discharge during heavy rainfall events like benefits are reduced flood frequency and intensity, protection of downstream settlements and stabilization of river flow, prevents of crop damage. Okay. Impacts of dams is displacements of people, some soil impacts and submersion of villages, loss of agriculture land, culture and heritage land, and inadequate rehabilitations is there. So, okay. Displacement and ecological changes is there. Okay. Mainly dams are powerful tools for development, but also causes uh, profound ecological and social consequences is there. Okay. Uh, Coming to the location and industry, location of industries. Industries location is a critical factor in balancing economic development and environmental sustainability. Poor sitting of industries can lead to pollution, habitat destruction, and public health risk, while proper planning supports sustainable growth. Like industrialization has been central to economic development, but without environmental safeguards, it contributes sorry, it contributes significantly to land degradation, air and water pollution, ecological imbalances. First one is the industrial growth versus environment. It means factors influencing industrial location like availability of raw materials and transportation infrastructure, availability of labor, access to water and energy. Okay, environmental impacts of poor industrial locations are air pollutions. Okay. Emission of sulfur dioxide and nitrous particulate matter, acid rain formation, water pollution, and land degradation, public health impacts. Okay. Second one is the need for environmental impact assessment. Environmental impact assessment is a systematic process used to evaluate the environmental consequence of proposed industrial or development projects before decision making. Okay. Coming to the next slide, solid waste disposable. Solid waste disposable is a critical component of urban development management. Rapid urbanization, industrialization growth, and changing consumption patterns and have significantly increased waste generation, making it one of the most pressing environmental challenges in cities. Solid waste includes any discard solid materials regulating the human animal activities that is no longer useful. um, Sources of municipal solid industrial agriculture and major urban environmental issues. Okay. In this main sources of municipal solid waste are definition. uh, Waste generated from households, commercial establishment and institution and test sweeping. Okay. Components of organic waste, plastics, paper and cardboard, glass materials and textiles. Environmental concerns are open dumping and leachate formation, methane emission, and disease vectors is there. Urban waste management in India is regulated under the solid waste management rules. Okay. Industrial waste. What is the industrial sources of manufacturing processes, chemical industries, and mining operations is there. Power plants. Okay. Types are hazardous waste like heavy metals and solvents, non-hazardous process waste, fly ash, sludge. Okay. Some agriculture wastes are the crop residues and animal manure, pesticide containers, irrigation runoff diseases. Okay. Main in the United Nations Environmental Program identifies the solid waste as a critical component of sustainable urban development. Okay. Mainly solid waste disposal is a major urban environmental challenge due to rapid industrialization and population growth. Sustainable waste management requires. Okay. Uh, Today's session is completed. We completed the land today topic. Completed the land management topic. Okay. We have only three blocks is there. next week we discuss about the next topics. Okay. Thank you. Thank you being with me. Okay.